Okay, a postulate, or the book calls an axiom. Okay, these, you're going to see these words all year. Postulate or axiom. The definition of those are just a rule accepted without proof. It sure is, yes. It's a rule that is accepted without proof. That's a postulate or an axiom. So how does that compare to the word theorem? What do you think a theorem is? If you had to guess.
Theory.
Yes, Mr. Brim. Yeah, this is a rule that can be proved. Oops, proved. So, a postulate is just a rule that is accepted without proof, such as gravity exists. Today is Monday, all right? Look, we know this. We don't need to prove it. It's a rule. It's a postulate. Theorem, however, is a rule that can be proved. So, a guiding question you might want to ask yourself in your notes is, compare and contrast postulate to theorem. How are they similar? How are they different? Okay, the first postulate of the year I'm going to teach you is called the ruler postulate. So, if it's a postulate, do we need to prove it? Yes or no? No, how come? Because it's a rule that's accepted without proof, so we can do it. Okay, here is the ruler postulate. So, draw yourself a line. Remember, lines go off in either directions, okay? Give yourself 2 points on that line. I can call those points A and B. I can also relate those points to the coordinate system, and I could give those a coordinate x1 and x2. So the B's, I can label them by points. X sub 1, x sub 2, I can label them by coordinates. Okay? And the distance from A to B, so segment AB, is the absolute value of x sub 2 minus x sub 1. So this is important. This is the absolute value. And we call that length AB. This is nothing new. You've been measuring things with rulers ever since someone put a ruler in your hand. That is the ruler postulate. We will use that today in our assignment for tonight. Okay, feeling pretty good so far? So axioms versus theorems, and this idea of the ruler postulate and how to measure something with a ruler. I'm pretty sure everyone can measure stuff with a ruler. Okay, I want to teach you the idea of betweenness for the third box here. Okay? So, betweenness. You can say when 3 points lie on the same line, you can say 1 point is between the other two. So let me give you a picture. Okay. Here's a line, right? And I know it's a line because it extends off in both directions. And I'll put a couple points there. But A is on the line, B is on the line, and C is on the line. I want to compare this picture to this picture over here. Okay, I have a line, and I'll put 2 points on it. I'm going to put D, and I'm going to put point F, and then I'm going to put point E not on the line. So, when we're talking about betweenness, okay, the key idea for betweenness is that they have to lie on the same line, okay? So, taking a look here, we can say point B is between A and C. Why can we say that? Because they are all on the same line, so they are collinear. What can you say about this picture over here? Point E is what? Is not between point D and F. And how come we can say that, everybody? Because point E is not where? It's not collinear, it's not on the line. So there's the difference between this first picture of A, B, and C versus D, E, and F. Is everyone okay with that part? This idea of betweenness? So in order for something to be between, it needs to be collinear. Okay, we're on the third box now. We've spoken about these three things: a postulate versus an axiom and a theorem, the ruler postulate, and the idea of betweenness. We have three things so far. Are you okay? Okay, can I answer any questions for you so far? Okay, we're going to move on to our second postulate of the day. It's one of my favorite postulates in the whole entire world. I'm not even kidding. It's called the segment addition postulate. And the key word here, ladies and gentlemen, is addition. The segment addition postulate. Okay, I want to draw a line for you. It looks like this. And I'll put some points on that line, okay? I'm going to put point A over here. I want to put point B over there, and I want to put point C over there. Would you call those points collinear? Yeah, they all lie on the same line, right? So, could you say point B is between A and C? Yes, you can. Very good. Cool. Okay, I'm going to tell you that this distance from here to here is a segment of the line, right? What segment of that line would that be? How would you label that segment? AC. Very good. This is segment AC. And then of course, we label it appropriately with a little line segment over the top of it. Now let's go below here. What would you call this segment right here? AB. Very good. And then to finish it off, what would you call that segment right there? BC. Great. Now, here's the question I have for you to understand. What is the relationship between segment AC and the two segments down below, AB? Oh my God, that is pure genius right there. That is absolutely pure genius. Did you hear what he said? Yeah, he said this, right? He said AB, segment AB plus segment BC is equal to segment AC. That right there is super, super important, right? Because it's an algebraic expression. Right now we have an equation that relates these two together. And we're going to use that. Okay, let me give you a better example of this. I'll draw the exact same thing and we can visualize exactly what Wyatt just said. Okay? So I'll draw the same picture. Okay? Call you A, call it B, and call it C. Okay? If I told you that AB, the distance from A to B, was a distance of 5 units, and the distance from B to C was 3 units, how far would it be from A to C? It would be 8 units. And how would you get that? You just add the 5 and 3. Now, are these two things saying the same thing? Yeah, they are, right? They're both saying the exact same thing. One just uses letters and one just uses numbers, but they both mean the same thing, okay? Okay, great. For the fourth, or this is the fifth box, isn't it? I'd like to do example number 23 on page 21. So please open your book. Page 21, I want to do number 23 with you, okay? If you don't have your book, make sure you are bringing your book to class every day. And the picture looks like this while you get set up. Yo. It's on the board. Yeah. Today's Monday. All right, here's what it says. It says page 21, right? Example number 23 on page 21. Can someone give me some useful information about what they see on page 21, number 23, please? How can I label my diagram here? Yeah, they're all collinear. Very good. What else can I know? How far is it from P to T? Yeah, 20, right? So all of this is 20 units, right? Okay, great. What else do I know?
QS is 6.
Yeah, from Q to S is 6 units, right? What else do I know?
PQ equals QR.
Oh, yeah. It says that PQ is equal to QR, which is equal to RS. Which means they're all the same length. Very good. And there's one other piece of information that I know. What is it?
That we need to get QR.
No, don't I know, like PQ, right? Doesn't it say PQ is something?
Equal to QR.
Doesn't it say PQ is equal to 4 somewhere? In the directions?
QS is equal to
Yes, doesn't it say that?
no. PQ equals QR. PT equals 20, QS equals 6, and PQ equals QR equals RS. Find each length.
This isn't 4?
No. It
Doesn't say PQ is equal to 4?
No.
Oh, okay. Well, fine. Perfect. No problem. Now we know, right? Well, it should be 4. Okay, what's our goal?
Find what QR is.
Okay, let's find QR, right? Okay. We're going to find segment QR.
Are we ready?
Yeah, this is part of our box. Okay, so our goal is to find from Q all the way to R. We're going to use the segment addition postulate. So, if we know that PQ and QR and RS are all the same length, and we know from Q all the way to S is 6, how far is it from Q to R? Yes, there you go. So, QR must equal 3 units. And the last box, I would like to do example number 31 on page 22. So please find number 31 on page 22 and read the directions to yourself. Mm-hmm. Yep. Page 22, number 31. You're given a few things. Can someone tell me what you're given? What are you given on number 31? Line segment LM is how much? 3x. Yeah, that's 3x plus 8. What else do I know? MN line segment is how much? Thank you, 2x minus 5. And I also know that LN equals 23. So if I were you, to solve this, I would draw a diagram. So here's the picture that I could draw for myself, okay? Here's a line, okay? And I know that L is over here, and I know N is over here, and it tells me that M is between the two of them. I also know that LM is a total distance. All of this is how much? No, not quite. Yeah, that is, there you go, that's 3x plus 8, right? Okay, how much is all of this? Yeah, that's 2x minus 5, right? And how much is all of this? All of that is 23. So my goal is to solve for x, so I'm going to use the segment addition postulate. Who sees how to set it up? Oscar, what do we do? You make an equation. 3x plus 8 plus 2x minus 5 equals how much? What's the total length? 23. You got it. Okay, now we need to add these like terms. So we're going to add 3x and 2x and get how much? Good, 5x. We're going to add 8, take away 5. How much is that? So plus 3 is unequal to 23 on the other side. I'm going to subtract 3 from both ends. I'm going to get 5x is equal to 20.